Okay, for today, I want to review the stuff from 2 days ago with the question 1, which is, what if you just have a big fraction? But if you can factor it, you should. Everybody write this one down and solve it with your partner. Show what it factored to, show stuff canceling, write the answer nice and clear so if somebody else were to grade it, they can read it. Okay, and you are encouraged to work with the kid next to you and say, are you getting this? Is that what you got when you factored this? Okay, question 2. This is just on a blank notability doc for right now. X squared plus 5x. That always freaks people out. Like, where's the last number? What if it doesn't have one? Okay. You could put a plus 0 there if you want, but you don't need it there either to factor it. And then over x plus 4. And that's just to remind you that even if you do your best and you factor it right, sometimes nothing cancels. Plus 5. How the heck are you supposed to add that? They don't have a common what? Denominator. So figure out how to make it so they have a common denominator. Hint, first of all, just give it a denominator of what? 1. And then figure out what to do. Don't say it. Figure it out with your partner. And then last but not least, the blue question, which is, I want to pause for a second because I almost messed up and made it not factor. So I'll write that one out and then put the video back on. Okay, there, I got that third one done now. It's a divide problem. Don't forget that divide really, with a simple little flip, can turn into a multiply problem. All right, pause for a second while you try to get 3 out of 3 here. All right, so here we go. On the top row, let's see if we can get somebody to do this one. Random person and their partner. It's going to be row 5. Person 3. That's you, Mr. K. Yep, get the easy one. Lucky you. What's factored on the top? What's the factors on the top? That's correct. And on the bottom? Yup. And then those cancel. And you got x plus 1 over x minus 4. Raise your hand if you had that one right. Awesome. Now where we go next will be about the horizontal and vertical asymptotes of that. But I'm just going to start with this. What would crash it? What would crash our new little function here? 4 would. Because if you put in a 4, you don't get anything. By the way, that means there's an asymptote there. That makes an asymptote there. Because when you put in 4 in the function and you get nothing, it's because there's an asymptote there. If you got a number, there wouldn't be an asymptote. All right. Next. Gentlemen? Not now. All right. This part, factors, although it's kind of almost irrelevant because it won't cancel with this x plus 4. So now I'm going to modify my if you can factor it, you should, into you should factor it if there's a chance stuff will cancel. Okay, but I can tell it there's not an x plus 4 in this, and so I'm not even going to bother factoring. Okay, that's like a little more advanced factoring is when knowing when not to factor. All right, guys, it's continuing. Please stop. All right, and then on our right side here, I'm going to multiply by x plus 4 over x plus 4, and that makes it, on the top, 5x plus 20. This is 5x plus 20, and that goes with this, and the 5x can go with the other 5x, and so I got x squared plus 10x plus 20. And a lot of kids are like, I see a 4, I don't see a 20. It's because of the 5. There we go. All over. And then a common mistake is people think it's adding, so I should add the 2x plus 4s. Nope, they have a denominator that's common of x plus 4. Now, is there a chance that the top could factor? There's a chance. If I used x plus 4 and x plus 5, would it work? All right. 5, 4 would make 9. Oh, it's so close. It would make 9x, but not 10x. Okay, so it's close. If it would have factored to it x plus 4, of course I could have canceled, but there's nothing else to cancel, so it's done. Raise your hand if your group gets credit for that one. Okay, good. And then the last one, it's a flip and multiply one. I like to still factor. If you can factor, you should. In a problem like this, there's so much stuff that if nothing canceled, it'd be really complicated. So it's very likely something will cancel. That factored to x plus and x plus, nope, it can't do that. I have to be minus and minus. You know why? Because it has to come out positive, but give you a middle term that's negative. So then it's minus 7 and minus 1. All over x minus 4. Nothing canceling yet. But when I change this to times, I have to flip the second fraction, and I'm factoring it also. And this factors to x minus 4 and x minus 1. Did I get that right, I think? All right, now do you see something that cancels? A lot of things. Some people don't get that you can cancel across to the other fraction. It's okay. And then the x minus 4's cancel. And my final answer is x minus 1, x minus 1. Would I allow that? Yes, I would, because it's in factored form. Would I allow it to be multiplied out? Yes, I would. X squared minus 1. Either one of those two answers is a good answer. Any questions about that? You think there's a mistake? Tell me what you think's wrong. Okay. Oh, you're right. You were right. This one was right. But when I multiply it out, it's x squared minus 2x plus 1. Sorry about that. You're right. I multiplied it out wrong. Oops. I should have left it with this, because I did say it was okay to leave with that. That's one of those things that happens on the test sometimes, is like kids take an answer they could have left alone, and they try to do one more thing, and oops, make a mistake, and then it costs points. All right. There we go. How many groups had x minus 1, x minus 1 as their final answer, or the multiplied out version of it? Awesome. Then you're in the right spot. As in, that's the stuff you should know so far. That's not like the most complicated problems ever. That's kind of like normal problems from what we've done so far. So don't move out of your group yet, because you're going to need somebody for this next part. My last class found this kind of confusing. Now, I will admit, I made a mistake. I switched my x and y on the first example problem, and that got them all confused. I won't do that for you. I'll be very, very, very careful not to do that. All right? But do you get that if I have an equation like 1 over x, that's the butterfly equation. It's like a standard parent graph you should know. Please sketch it right now and see if yours and your partner's look the same. Sketch that one. Yes, ma'am. Ah, okay. So we're going to have you just slide up and join the group in front of you. Actually, why don't you slide over? It's easier for you. Just slide straight over. And you can join L's group. Now, a lot of people have a couple of swooshes. I want you to have 2 distinct points. All you need is 2, but there's 2 points that are perfect. Like, 2, 3. They're perfect. They don't have weird fractions in them. Put 2 dots in the 2 critical spots. If you don't know where those are, you need to learn where they are. Put 2 distinct dots on your graph where the key points are. All right. Do you remember that all the parent functions, be it the absolute value, this isn't the right one, but it goes through 1, 1. This one, which is x to the third, that goes through 1, 1. See where I'm going with this? Okay. They all go through 1, 1. All the parent functions. The square root, that goes through 1, 1. The U-shape, the parabola, goes through 1, 1. Everything goes through 1, 1, including this one. So that's one of your key points, is you should have had a dot right there, and that would be at 1, 1. Okay? And then, of course, there's one like this, and then there's a key dot right there at -1, -1. Okay. So that's the parent function. But, of course, we're going to move it around. I want to go to, before I do that, I want to remind you what we had for like this kind of question. Do you remember that deal where we were like, this one goes, up 3 and to the right 7 and that kind of stuff? Would you please make a list of the 3 things? Use words like horizontal and vertical and left and right. What are the 3 things happening here? I think some of you may have forgotten where the horizontal versus the vertical stuff is. This is a parabola that's being moved around. Pause for a second while you give that a try. All right, you should have said I'm not necessarily doing these in order. I didn't ask for you to do that, but I'm going to start on the inside. Do you guys remember me saying that the good idea to start on the inside? All right, so I'm going to move this thing to the left 3. How many of you guys knew that? Left 3, okay, good. Then this is down 7. And yes, and I should have really done the reflection first because this comes before this. I'm going to squeeze that in there, moving this down a little bit. That's a vertical reflect. Now, remember me saying that there's more than one order that was okay? That does not mean everything's okay, but there's more than one order. You could start with the outside first and do all that stuff first. So what would that have made go first? If we started on the outside, that would be first. That's my advice to you, because this test has a little bit of that order stuff in it, is if you have multiple things to do, start on the outside. Now, some people are like, okay, wait a minute, Mr. Server, I wanted to know which axis it goes over. A vertical reflect does tell you that. It just doesn't tell you that super obviously. Vertical means up and down, which means this way, which goes across the x-axis. All right. All right, so now let's see if you're ready. Typical problem today. I'm not going to give you the really hard one yet. I'm going to give you the medium one. Would you agree that that is the butterfly shape I made you sketch before, except moved? Would you please figure out where it's horizontal, you know what that looks like the horizon, where its horizontal asymptote is, the dotted line that would run through the middle of the function, and where the vertical asymptote is. Sketch it first, and it's a lot easier to like slide it over and figure out, okay, the vertical one's here, the horizontal one's there. And then I want you to label it, because that's one of the hardest parts. Sometimes kids know that it has an asymptote of like x equals 2 or whatever, but I don't know if it's a horizontal or a vertical. Horizontal asymptote, vertical asymptote. Try to figure out which one's which. One of them's y equals something, one of them's x equals something. And from looking at your picture, you can get this. You don't have to have a special formula or anything. You just look at your picture. If you did it right, you'll know what the asymptotes are. Now pause for a second. We'll give that a try. All right. Just to solve a few arguments, it moves left 8, which is a long ways to the left, and down 2, which means only down a little bit. Okay, so how many of you had the asymptotes generally? I'm going to use 2 different colors to make it more clear. You have one asymptote going this way, and you have the other asymptote going that way. Raise your hand if you had that generally right. Okay, awesome. Now which one's which? Okay, well I think you know horizon and goes with horizontal, right? Okay, and I've also said these dumb little words to you before to try to help you remember which one's horizontal and which one's vertical when it comes to x and y. Horizontal, so the horizontal asymptote is a y equals thing. And if you know which one the horizontal one is, which color is it, the horizontal one? Which color is the horizontal one up here? It's the green one. It's y equals, what does that look like? Does that look like it's been moved down 2 or 8? What do you think? It's down 2. So y equals -2. Now, this is one of those counterintuitive things. Would you agree this is the x-axis running alongside it? And that's why some of you felt like that should be x equals on the green line, but it's not. That green line is y equals -2. All right, next, this pink one. The pink one is the vertical asymptote. So I have said zertical to try to help you remember it's x equals goes there. And it seems to me like it's been moved over a fair amount. In fact, what do you think? 8. But let's be careful. Is it x equals 8 or x equals -8? -8. It's been moved to the left, so it's -8. Would that follow with the whole you can't trust the inside thing? It does kind of work with that. Okay, so that's how you can tell where the asymptotes are. You basically say, where did they get moved? All right, one more thing. if you're concerned on the test, like I'm feeling like I might have something backwards or screwed up, you can always make your best friend in graphing. The XY chart is best friend in graphing. So you pick some nice number that'll work nice. Do you agree that 9 does not work nice? It's 1/17 minus 2. Pain in the butt. Don't want to do it. So don't pick 9. What's the smart number to pick? -7. I like it a lot. Because then I'm going to have 1 over 1, which is 1. 1 minus 2 then gives us -1. Does -7, -1 look like it could conceivably be on this graph? Yeah, I think it's that one, but I'm not absolutely positive. It could be this one. I don't think so. I'm going to try going a little past it and try -9. Do you get why I picked -9? It's going to work, guys. Everybody think for a second. What's -9 make? You stick it in there. Then you get 1 over -1, which is -1. And then what's -1 minus 2? -3. -9, -3. Does that seem like feasibly that spot right there? Yup. And there we go. Do you get how that helps you to make sure you didn't mess something up? The XY chart is especially good at just checking to make sure you didn't slide it by accident to the left or to the right instead. You know, like do the opposite of what you should have. All right, so the only last twist is when we do this. Negative of 1 over x plus 5 minus 1. Well, hint, I had suggested that in this case, you do it from the outside in, which would mean the first thing you do is a flip. So the parent function is this shape. I call it the butterfly because it sort of looks like butterfly wings when you put it together with the x and y axis. And now I'm going to flip it. Now, some people get confused on, do you mean flip it this way or that way? It doesn't matter. Both ways come out the same. It doesn't matter which way you flip it. If it starts as the blue and you flip it down, it could be like that, and then flip it up, and it would be like that. Or you could think of it as a left-right flip. It doesn't matter. This is the only function where flipping it vertically or horizontally gives you the same result. Then, I'm going to get rid of my original. That red one is now the flipped function, which then we can move it 2 different directions. All right, I'm going to pause for a moment. I'm going to ask you to give me the 2 answers I need, which is what are the horizontal asymptotes and the vertical asymptotes. And I said it plural because sometimes there's more than one. In this case, there's only one. But sometimes you're going to have 2 or 3 vertical asymptotes. When we get done with this unit, you'll be able to handle as many as 3 vertical asymptotes. Technically, you should be able to handle any number of vertical asymptotes, but a typical test question on the very end, the hardest ones, might have 3 vertical asymptotes. All right, Dice of Destiny, who am I supposed to call on here? Row 1. Person 6, well, it goes 1, 2, 3, 4, and then it cycles back again, 5, 6. Tell me what to do. Move it which way, first of all? This thing. Left 5, I agree, and then? Down 1. I agree. I'm putting my asymptotes in 2 different colors. There's this way, and there's this way. And now, which one did you call the horizontal? Was that the green one? And what do you think it is? What is -5? This is important. If you say X or Y wrong, you get the whole thing wrong. Okay, if we're doing horizontal asymptote, Y. Horizontal, remember your horizontal? Y equals what? It is not -5. How far down did it move? Move down 1. See, that means down 1. Okay, so -1. Raise your hand if you had y equals -1. Okay, good. Then, Dice of Destiny, another group to call on for the other one. It's row 4. Person 4. 1, 2, 3, 4. That's you. F. Vertical. X. Vertical. Keep going. And it's this line right here, which is -5. I agree. Why is it opposite of that? Because you don't trust stuff on the inside. Raise your hand if you had those two right. Cool. Then you have learned how to do vertical and horizontal asymptotes, including reflections. The last thing that's on your little homework is a reminder of what domain and range means. Domain is the X stuff, like the left, right. Range is up, down. Okay, so these are hard to do the domain and range for. I'm going to do this one, and let's see if you can do the next one. Domain is the X, and that means I like to think of it as this way, from this way to this way. Well, it goes forever in both directions, except it can't be one thing. As it goes, this is my electric fence that I can't get over right there. And that was at -5. So I'd say it goes from -infinity to -5. And then starts working again right at -5 and goes to infinity. Do you remember that? All right. Then, would you guys please write the range? By the way, when you put this into Schoology, it's a Schoology quiz today with only 6 questions, which is kind of nice. It's short at least. When you put in the domain and range, they have a U in there. They used a capital U. It's just a small thing, but you know, you type the wrong letter and you get the whole thing wrong. That kind of sucks. So use a capital U on the Schoology quiz. All right, FG. Oh, wait. FS. Yep. And if I was on Schoology, I'd write it INF. I'm totally fine with you using the symbol right now, but inf to -1. Very good. It stops working at -1 because it got moved. The asymptote got moved down there. And then it keeps going up until infinity. So how do I write that part? -1 comma inf. Nope, parentheses, because they don't touch. Can't touch this. All right. So let's get into the Schoology quiz and get started on that, and then you're going to get a bunch of time to work on it. So I'm pausing for a second. We'll pull that. So on this first one, horizontal is like horizon. Is it the 3? No. In fact, you can't even see it on there. But there's an asymptote running across at, what do you think? The first one is the horizontal. Horizontal like horizon. It's this way, and it's at 0. But be careful. It's like the x-axis, but it's not x equals 0. It's y equals 0. Y equals 0. I would use a lowercase y for that. All right, next up is the vertical asymptote, also known as the vertical asymptote. To remind you, it's x equals. Kids often forget to put that, and they just put a number, and then they have to get it marked wrong on the test even, too, not just a picky Schoology thing. If you don't have x equals or y equals, they're wrong. You got to get the letter in there. All right, the vertical asymptote is x equals, well, vertical is up and down. It's this one, and that is 3. There it is, x equals 3. Next, domain. We talked about this. Either work hard or you might as well quit. Some of you are like, it's Friday. I'm going to choose quit. No, don't quit. Don't quit yet. Getting some free answers. All right. Domain. Well, I'm just going to look at this pink lines here, and then what's the furthest it goes to the left? -inf. And then it goes until it hits what? What can't it cross here? 3. Until it starts working right after 3 and goes until positive infinity. No, you do not use brackets, because brackets are, in case you... Okay. On this one, it's asking what A is. Well, you never said anything about A. No, I didn't. You're right. But it's asking what number is that. And by the way, A can be negative. All right, so looking at this, that's the spot. It's trying to test you like, okay, you might know it's called a vertical asymptote or a horizontal, but do you know what this one is? Hint, it's the way it moved to the left or to the right. Looking at this graph, can you tell it moved to the left? How far? Do I put a negative 2 or a positive 2 right here? Positive 2 would mean to the left 2, so A must be 2. That makes sense? And then how about this? That's how far it moved up, right? All right. I think you can handle this. All right. I'm going to say that's enough of a help for today. And the rest of the time is work time, and it's a Friday. Enjoy your weekend. That's all I got for you for today.